So, Paul, would you like to introduce the speaker for us?
Paul O'Rourke, I'm a volunteer for the SIG. It's a pleasure to introduce Francisco Martin. He's an AI researcher and a serial entrepreneur. He's founded a series of really interesting companies, iSOCO-Intelligent software components, and then Strands, a company focused mainly on recommendation. And while he was at Strands, he co-authored a set of patents that were acquired later by Apple, mainly on music recommendation. And a couple of years ago, he started this company, BigML, that we'll be hearing about tonight. I think this is actually a member of a class of new companies that are emerging that are offering machine learning as a service in the cloud. And you'll see several others of these, and we'll hear more about them in about a month here in the Bay Area. Now, please welcome Francisco.
Thank you. It's great to be here. Thank you, Paul, for the invite, and thank you everybody for coming. And as you see, very soon my accent is very strong. So there is no machine learning application yet that can translate my accent. So if you have any question or you don't understand a word or anything, just let me know and stop me right there, and I'll be able to probably translate. Or we find someone in the audience that do that for me. I was also thinking of making the talk in Catalan, and I know that there was at least one person that will be voting in that direction. But anyway, so let me start with some questions. How many of you are machine learning experts? Have published a paper in KDD, ICML, or have implemented an algorithm that is proprietary and is running in a production system on a large scale? How many people here? Okay, good. How many people are machine learning aficionados? They understand the algorithms and they are capable of picking them and knowing the difference between using a neural network. Okay. How many people are practitioners? They're very familiar with Weka, R, and they are capable of using these packages to implement. Okay. How many people are newbies? They're taking the Coursera class in machine learning? Yes, a few too. Okay. How many people still think that machine learning is science fiction?
I think it's science fiction to still be an aficionado.
Okay. So why make machine learning easy? So I think I'm going to tell you why I'm doing this. So in early 2010, the Economist was publishing a special report on data everywhere, and I was traveling to Europe, and I was reading this article where it was talking about the huge amount of data that was out there, and about certain companies like Google or Facebook that they were using every single piece of data to improve their operations. And I was traveling to visit a bank in Europe that I have sold a recommender system for several millions of dollars. And we were just doing the delivery, and then the business guy that was about to run that recommender system was telling me, I don't like your recommender system. I was telling why, because he was telling because it doesn't use neural networks. I was telling what? Have you tried the system? Have you seen if the recommendations are good or bad? And he was completely against using our system because we weren't using neural networks. Why? Well, because when I was doing my master, I heard that neural networks were very good. That was the only reason, and they throw away millions of dollars in the recommender system just because they are guys that didn't like the and that you can see that in many companies still is what is called the hypo decision making. The highest paid person opinion is what led the decisions in many companies. They are not absolutely no data driven. So a month later, I was visiting the same bank, and they were asking me if I could help them to innovate in the risk analysis department. This time they have like 4,000 people working in risk analysis, and they were claiming that they were the best guys in the world doing risk analysis. There was a customer willing to have a new mortgage. They were very good at deciding if these customers should have that mortgage or not. And I was inquiring about the system that they were using, and I was telling, are you familiar with Hadoop? Have you ever used machine learning? No, there was a professor that came like 3 or 4 years ago. They gave us a seminar. That is everything that they knew about analyzing data. They were just sampling the data warehouse once a month, taking 3,000 cases out of millions and millions of customers, and they were bringing that to Access and just using some models that they were created in Excel 10 years ago. That was the way they were using to decide if people was capable of not paying their credit. So I thought that there was a very, very good opportunity to really democratize machine learning, bringing what certain companies can do nowadays because they have the best machine learning researchers and they have the very, very good machine learning engineers, bringing that to many other companies. Not because I like banks, but because I think that there are many, many other companies there that cannot afford to have these machine learning researchers. So, as you know, machine learning is the key component for making data-driven decisions, to develop smart applications, and also to build predictive analytics. There's a bunch of many of the analytics that you can see nowadays are just to look at what happened in the past. They don't help you to understand what is going to happen in the future. There's few applications where you can really use the data in order to make savvy decisions based on what happened before. So, and to bring machine learning to a project nowadays is very, very, very complex. Tools are very complicated and they don't scale very well. You try to use Weka with something that is in the gigabytes of size. It's very common that your computer crash or the process never ends. There's many issues to use the current tools, and the solutions are very, very costly. And you tend to find an expert that knows a lot about the algorithm part of machine learning and the industry part of the domain knowledge of an application. Is very, very complex to find these kind of guys. There's only a few people that really have been in both worlds at the same time. So, why make machine learning easy? The learning curve is very, very steep to go into machine learning. As soon as you start learning for a few months, there's a jargon, it's very, very specialized, and you need to get some math background in order to understand the algorithm. So trying to change them is a little bit complex. And additionally, most of the machine learning algorithms that were invented over the last 10 years, they were created for data sets that were fitting in memory. They were very, very small. So there are many of these techniques, they don't scale very well. So that is another complexity. You want to analyze a chunk of data that is over 64 gigabytes or 120 gigabytes. It's very, very difficult to do that. You can try these kind of things with MapReduce, with Hadoop, all these kind of new things, but again, it's very, very complex to do iterative algorithms on top of Hadoop. And there are many people that are trying to do that, but again, the complexity is increasing. So we decided to almost 2 years and a half ago to create a cloud-based service that was making machine learning very simple. And I think that we have been working hard in that direction, and I don't think that we can claim that we made machine learning simple yet, but I think it's simpler with BigML. Nowadays, there are more people that are using the service and they are implementing applications and they are capable of creating a machine learning backend in a matter of a week in a very, very easy way. It's something that probably a few years ago was impossible. So today, I'm going to give you a full demo of BigML, 10-15 minutes, and I'm going to show you everything that you can do from the web interface. I'm going to also show you how to play a little bit with the API. And then I'm going to describe what are the challenges that we are facing right now. And I think there's some very, very, very diverse ideas about what I think that is important to make machine learning simple, successful in the future. And then all the time that you want for questions. All right, so how BigML works? Very easy. You need to set up a data source, and this is the raw data. and there's a number of ways where you can get the data into BigML. I can mention a few later. When we have the raw data, what we do is we transfer the data in what we call a data set. That is a structured version of the raw data. We compute a number of statistics, and based on that data set, we're capable of building a model that has some predictive power that you can use to create predictions. All right? So there's a number of formats that we accept, from CSV, ARF, spreadsheets, and the data is something that can be in your drive, or something that can be in a remote location, and we can bring that even from S3, Azure, a number of different protocols to interact with data services. And what we do with the data sets, we implemented the way we transfer big data into small data is using string algorithms. We don't use MapReduce or Hadoop or anything like that at all. We tried that many years ago, and we saw how complex it was to build an algorithm that tries to do something interesting, and we decided not to use Hadoop in the company. I think as storage is great, but as a way to implement something sophisticated is very, very complex. So we use string algorithms, so we are capable of building a data set, a histogram for every feature in the data in just one pass over the data. We compute a number of statistics, you'll see that later. And when we have the data set, we build the model, and we wanted to build models that were interactive, models that people could understand. I think that one of the problems with machine learning is people talk about building models and creating models, but nobody can see these models. And you want to convince a business guy of accepting one of these models to change something in the company or to make a new decision. I think it's very, very important that there's a model out there. And I think that is something that is missing. There's no a nice way to see a predictive model right now, you know? I think that, and trees are fabulous for that, so we decided to do that with trees. And making these models actionable, making very, very easy to take that model and changing something in your company or your business, because you are capable of automatically use the model without much trouble. All right, and when we have the model, you can build predictions, and we offer a couple of ways to create these predictions, and we automatically create forms for people to use predictions. You'll see that in a second. And then we use evaluations that I start calling now pre-evaluations. This is a way to tell you how your model is, how good your model is going to be making predictions for data that wasn't used to build the model. All right. So everything that we do through the web interface is something that you can do also via our API, and it's a REST API. In fact, our interface is built on top of our own API. And then we have bindings for R, for Ruby, Java, Clojure, any language. Node.js is something that is coming in a few weeks, but we have for many languages. All right. We have more than 35,000 users right now, and we have more than 3,500 users that created more than 35,000 models so far. I think that the numbers are bigger, some of 4,000 today. Anyway, so let me go to the demo. All right. So everyone can sign up in BigML for free, and you're gonna get a number of credits that you can use to test a number of things. And if you operate the system in what we call development mode, everything under 1 megabyte is for free. And then you can buy more credits, and now we're bringing subscriptions. I'll explain that later too. But after the demo, I'm going to give you an email address, and if you say your username in BigML, you're going to have a free subscription, a free month that you can use BigML as much as you want, and different sizes. I think that we're going to be limiting to 1 gig. But if you have someone here was mentioning before, I have 35 gigs of data. If you want to something bigger, 64 or a terabyte or whatever, just send me a note, and we can grant that for free, so you can pay everything for a month for free. All right, so let me use this username. All right, So when you get into BigML, what you have is a dashboard where you can see all your sources, or your data sets, or your models and samples, predictions, evaluations. It's a nice way to get everything under the same structure. All right. So and let me start with a little example here. How many people know this data set, the diabetes, the Pima Indian diabetes data set? Very popular in machine learning. I think that okay, a few. All right, so I'm going to use that for the demo, but we can use many others. When you sign up, you're going to find that you have like 10 what we call promotional sources that you can use. There are some data sets there that you can play with, and then you can try how the system works. All right. So to bring data to the system, very fast way to do it is just drag and drop the file there. All right. So this was automatically uploaded to the cloud, all right? And what we have here is automatically we are capable of identifying if a feature is numeric or something is categorical, all right? There's all kind of configuration parameters that you can set up here if it's coming in a different language, a separator, if the data comes with a header or not, if there are missing tokens, you can set up that, all right? But usually, everything that comes in a tabular format is we parse that very well, and we are capable of identifying there are sometimes that certain things fail, but I think that we are doing a decent job of that. All right. So when you have the source, you can create a data set. All right. You can also there's a configuration here. You don't want to analyze everything at the beginning, just sampling or something. You can do that, but let me create a data set in just one click. All right. That was very fast. This is a relatively small data set. All right. So we were capable of building this histogram for every of the features in the original in the raw data. All right. And by default, we consider that the last feature in your data is the one that you want to predict. Is the what we call the objective field. All right. But if you want to
what field?
Objective.
Mm-hmm.
All right. So if you want to change that, you can come here and you can say, well, I don't want to predict diabetes. I want to predict age. All right. So that is very easy to change there. Or there's all kind of configuration options. You know, you want to sample the data. You know, you want to do something more advancing, like you want replacement or not, or the ordering in the data is something important because we shuffle the data in order to build the algorithms. You have something that is already shuffled before sending to the system. It's time that we are going to be saving during the computation for you, right? But that is something a little bit more sophisticated. Our goal is to be able to just in one click building a predictive model. All right. So we do this in online fashion. That means that every intermediate version of the model is something that you can already use. If you were analyzing a terabyte of data and you want to use to start making predictions before everything is analyzed, something that you could be doing. And after a couple of iterations, the model is built. And the model is, as I mentioned before, is something that you can navigate. All right, you can interact. You can see. I think that everybody here is familiar with decision trees, more or less. I don't need to explain the details, but I think that we do something very cool where we show you the histograms for the training set that we know, where you can see how the data is flowing. The width of the branches means how many instances are flowing down that branch, until you get to a leaf where you get one of the predictions, and on the right side you can see all the rules that making that segment or that subset of the data. All right. There's something very cool here where you can filter. You can say, well, I only want to see the tree that is where the leaves are supporting between 5 and 10% of the data. All right. So you can filter that way, or you can say, well, show me the things that with a very high confidence. All right. So I can go here and I can see that when I get to one of the lists, the confidence is going to be always above 50%. All right, even I can go higher. All right, 75%. So now I see like the rules that are where we have very high confidence that something is going to happen. Right. So, or I can go and I can say, well, show me only the part of the tree that are classifying things with people having diabetes or people not having diabetes, right? So there's all this kind of filtering here, all right, that can help you to understand better what are the relationships in the data. So I think that these kind of things are very, very powerful to look at the past, you know, to see what happened in the data. It's a very good explanation of what you have in the data. And we are seeing that many people, many marketing folks, they start seeing the data in this way and they love it. They spend hours analyzing why certain things are happening this way. We know that the trees are good generalizing, but they are not very good. But when you compound together these trees in an ensemble is when you can get something that generalizes very well, and we're going to do that in a second. All right. So something that more about the model, something that we invented a few weeks ago is or at least we released to production a few weeks ago, is what we call scarce trees. And this is a visualization that is not new, but using this visualization for showing the different parameters of a decision tree is completely new. And only at a glance you can see where are the parts of the tree with high confidence or with low confidence. You know.
What do you call that view?
Sunburst.
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 All right. And you can color. This is representing the whole tree. All right. If I go to the other view, you see that at some point in time we are printing the tree because otherwise it will be very, very complex to see the tree in the screen. All right. So we are limiting the scenes that you. And I don't know you have ever tried to print one of these trees that Weka creates, you know, with thousands of nodes, you know, and it takes a few sheets of paper to put all together, you know. So this is, we were limiting that here, the size and the way you can interact. And here, we decided to show the whole tree just in a very, very small picture, all right? And you can color also by prediction. So you can see what are the parts of the tree that are predicting that someone has diabetes and what are the part of the tree that someone doesn't have diabetes. So you can inspect what are the rules in a very, very easy way, all right? Or you can color by feature, you know, by the split that every node in the tree is doing, and then you have something more colorful, but probably that doesn't give you that much information, all right?
So they give the same view of the data, the tree versus the sunburst. Is there a way to like you do with the tree, you can look at a portion of the tree? Can you do that same with the sunburst?
Not yet. But we think that what we're seeing now is that people are happy seeing everything. You know, it's very quick to go to. You need to get a very, very huge tree, you know, in order to need that filtering. And I think that we're using here the radiance in order to compute how it's like what is the support in the original trees. Here we're using the radiance to create the two childs that the root node has, you know. So I think it's a very, very, very like simple invention, very nice way to visualize trees, and nobody thought of this before, you know, in many, many years. And I think that there are people that start liking this way to see the data, all right. And I can why we invented this a little bit later. It's in the challenge. Okay, so what else can we do with the trees? All right, so once I have a tree, I have a model, I can transfer that into rules. And this is something. This is a request from a guy that has been working in analytics for a while, and he was telling us, look, those models that you have are very cool, very interactive. But the CEOs and working on. They won't implement any of this cool decision making if they don't see a printout of the rules in a piece of paper. So I need a way to put that into rules so that this guy reads this, and it's amazing. But the work still works that way, you know. So but we export things to BigML, that is the standard in the industry for predictive modeling. BigML is very, very heavyweight, so we created our own version that is called JSON PML, and it's something that our trees, when we are sending our trees to the interface, we are using JSON PML. Our API returns JSON PML. It's a lightweight version of PML. BigML. All right, we can also generate Python automatically. So this is when you start learning machine learning, many people tell you, well, you can program a computer just instruction by instruction, but you can just give the data to the computer, and the computer is going to be learning a model. So this is a very nice, very instructive way to see, well, I give some data to the computer, and now the computer has a piece of code that implements the model, you know. So Ruby, a number of languages, scarce, and we give you also a nice summary where you can see the distributions for the data, the distributions that the model generates, the importance for every field in the model, a number of things. Even if you want to have now a Hadoop ready version, if you want to make a classification for millions of data points once you have the model, so we create a version of a little Python script or Ruby or Java that you can run in your Hadoop cluster, and now you can just classify millions of data points very easily. All right. So that is regarding the model, and now we can also use the model to automatically generate a form where you can input some things here, and now you can generate a specific prediction. All right. Here, in this case, it's false, and the confidence is 34%. All right. So these predictions can be also generated question by question. All right. So you don't want to. You have something that have many fields, and you want to fill out all the data at the same time. You know, you can just go question by question. Age, BMI, diabetes pedigree, and level of insulin, and finally I have a new prediction. All right, I can save, and that goes to my list of predictions. All right, what else we can do here? Let me show you a few ways where we can bring data to the system, and we have when you go into your account, there's a number of marketplaces that you can bring to the service. In this case, I'm going to show you an integration with Azure Marketplace. All right, where I can come here and I'm gonna take the car registrations in Barcelona, and I'm gonna be bringing these records from Azure directly from the marketplace, all right, using OData, and I have now this data set here very quickly, and I can create a data set, just one click, and one more click. I'm going to be creating a model that is going to be predicting the total year registrations in Barcelona, all right? Just took me like 2 or 3 clicks to do everything, all right? Very fast. All right, so there are many other ways you can bring data. You know, I can go to S3, and this is an S3 iris, and I can bring that immediately here too, you know. And in that way, we are allowed to bring up to 5 terabytes of data. You're using an S3 system. It's a very easy way to bring data to the service. All right, so now let me do something. I'm gonna take this diabetes data set. All right, I'm gonna call it ACN. All right, and now I'm gonna just I'm gonna use this in one click. I'm gonna be splitting that data set into a training and a test set. All right. That is something that is relatively easy to do, but if you want to do that programmatically, you start to implement sampling, a number of things, and sometimes it's a little bit more complex. So we have now 2 new data sets, one with 80% of the data and one with 20% of the data, right? So I'm going to take this data set to build a model, all right? And it's the same model that I did before, but it's only using 80% of the data this time, right? And now I'm going to evaluate that model with the 20% of the data that the model didn't see. Okay, it was data that wasn't in the training data. I was splitting into disjoint subsets, right? So just one click, I'm going to create this evaluation. All right, I have a number of performance measures here: the accuracy, the precision, recall, and I can even see this how this behaves by class. You know, I can compare now by class, and I can compare with a model that that will be making decisions just based on the mode, or with a model that will be making decisions based on a random decision, right? So I go back to the data sets. I'm going to take the same 80%, and now this time I'm going to be creating an ensemble, right? Just one click, and this time it's going to be creating 10 models at the same time, all right? And here we are just using bagging. We are just taking 100% of the data, of the 80% of the data, we are taking that full 80%, and we are using a replacement to build every single model here. And you see the distributions are very similar, you know, but there are some little changes, you know, that made that the model are different. All right. So now I'm going to be evaluating this model with the 20% before, and hopefully the accuracy will be much better than just using a single example, right? This case is 74%, right? If I want to make sure that accuracy was good, I'm going to be comparing now with the other evaluation. This is the model versus the ensemble. So I improve in like six points in absolute terms in the accuracy, just using a little trick, a statistical trick of building this ensemble, all right? Just one more click, all right, and I have the ensemble. So what else I can show you here in the, well, when you have an ensemble, I can go and I can generate predictions very easily too. The same way that I will generate a prediction for a single model, but here I can see how the different models are voting together, you know? And I can go and expect, well, why this guy is predicting false. There is something specific, you know, in that particular model. If you want to expect that, you can go and expect. Sometimes when you start playing with ensembles and random forests, they start becoming very black box oriented, and you cannot expect what is behind. Is a little bit more difficult. We're still thinking that we can invent a nicer way to visualize ensembles. So we're working hard in that direction, so that by a means of some bars with another idea, we will be able to visualize how an ensemble makes predictions in a very nice way. This is still a little bit complex. Okay, so what else you can do with the application? Just to finish, let me show you one more thing. I can take this model now, and I can say, well, this is a super cool model. All right, and now I can decide if I want to make this model public, so other people can come and can use my model to make predictions. This is what we call a black box. So that people will be able to use the model. If I have a very nice piece of data and I want other people to use that data to make predictions, but without seeing the data, without accessing to the model, I can use this version, all right? And I can charge for it if I want, you know, how many if I want, or I can charge for people that download the model and use the model for whatever they want, all right? So I'm gonna be making this, I'm gonna charge $99, hopefully I make some money. And I go to the gallery, and now I have in the public gallery, there's gonna be this model. It's gonna be there, you know, and other people can come and buy my model, and I'm gonna be making some money with that happen. All right. I can go, for example, this model here that is free, and I can also buy. This is how the way it works very easily. Now I'm cloning the model to my own dashboard, and I have the model that another guy created is in my dashboard right now. So I can use that to making predictions, and I can export that to any language, and I can use it. Okay. So as I mentioned before, the way the application works is using these credits, but now we're giving these free plans, so you can use the application as much as you want, and you send me your email, and I have the email address now in one of the slides. So I think that this is most of about the web interface. All right. In the gallery, you can see models that other people build, or you can see also data sets that other people build. All right. You can go and directly get a data set if you want. And most of the data sets are free, and we don't charge you for storing data sets that are free, this kind of thing. So it's a very nice way to play with data, to learn. We have many research institutions, many universities that are seeing this as a nice way to explain machine learning to people. Very compared to buying a license from MATLAB or SAS or anything like that, that is very complex. I think that they like this idea. Okay, so now let me show you how to do these things from the command line. You know, when you see that this is very easy and you get used to click here and there, you know, you see that well, probably I could go faster just using the command line. You know, it's always that. So I can use a command line that we created that is called BigML, and now I'm going to use the iris that they already have here in my desktop, and I'm gonna do everything that I did before. Or I'm going to use the diabetes. Diabetes is there. Okay, everything that I did before, and I call this ECN2, even an evaluation, just in one line. All right, I'm gonna take the data set that is in my desktop and loading that to BigML. I'm going to be creating a data set. When the data set is created, I'm creating a model, and when the model is created, I'm creating an evaluation, and when the evaluation is created, I have a bunch of data here in my local drive now that I can use if I want to run predictions. I could be using the model that is local in my desktop. But if I go to the interface, something happened. Is I was using my regular user, but let me repeat that. You know, this is the way you set up your API key is very easy. You have that little widget on the top. You know, I copy that, and in order to see that here, I'm going to repeat just the same line. It doesn't take that long, so I'm going to be repeating the same thing. And model. Before everything was created in my other account, my regular account. Okay. So if I go here, I have now ACN2, I have the data set 2, I can go to the model, and I can also see the evaluation here, all right? Everything in just one line. So that is very easy. You want to play, you want a small data set that you want to figure out something about it. It's a very, very easy way to do that. And now let me show you how to do these things from Python. I can, from BigML, I will import BigML, and now just doing this, I have direct access to the API. It's very, very, very simple. I'm going to create a source now, and now I'm going to be creating a source. Let me use this time iris. And now I'm going to create the source is here. What we have is like a JSON object that represents the source, you know. And now I can take the source. I'm going to create a data set. Using the source, very easy. And now I'm going to use the data set to create the model. Very easy too. I have here the model, and now I can create a prediction. The model, and now I'm going to give some data. Okay, sepal length, let's say 3, and I have a prediction, and I have a nice pretty print here for the prediction, and I can see that the species is Iris virginica for that input. Very, very, very easy. You know, this is just a simple example, but can give you an idea how easy it is to bring everything to the command line, or everything to a cell like the Python interpreter, and everything is here. You know, this iris is now here. I have my model here, so it's a very, very nice way to use both worlds, you know, the command line, your desktop, and keeping everything in the cloud. All right. So let me go back now to the presentation. Do it here. So you send an email to acm@bigml.com with your username. We'll be giving you, probably someone in the office is connected now, you will be receiving the subscription immediately. You want to play now, or probably in the next few days you can do that too. Okay. All right. So I think that what we built so far, there's many decisions behind the scenes, many things that we need to make, and sometimes hard decisions in order to build a system that was simple. And I think that something that was very helpful to make those drastic decisions is that we were building the company with almost no resources. We just invested in the company $2 million so far. And my previous company, I raised $55 million for my previous company. It's a huge amount of money. And then when you have so many resources, you start doing many more things that you shouldn't be doing. You know? So just building something with a scarcity of resources is very nice way to keep you focused and then to make the right decision for everything. You know, and I think that we're playing with that. We are receiving offers to get more resources in the company, investing much more money, but I think that we want to keep the number very limited because it helps us to keep the focus. So I think that one of the key challenges is the breadth and depth of machine learning. It's something that there are everything I was mentioning before. What BigML is doing now is supervised learning, and as you know, there are many other ways to do machine learning: supervised, semi-supervised, reinforcement learning, learning to learn. You know, there's many different fashions, but we decided to focus just on supervised learning, right? So then there's many ways in which you can implement a supervised or solve a supervised learning problem. And this is one of the questions that we have been receiving very often. When are you going to be bringing the next algorithm? When are you going to be? And sometimes we ask why you need another algorithm, you know? And I think that this is the mindset of what many people in the machine learning research community, they have been used to try different things, to play with different things, you know? And I think that our idea is the opposite. Can we simplify this in that way? It's like when the iPhone was first invented, you know, there are many people laughing because they only have the iPhones, they only have a button, you know. There were people laughing that was impossible to interact with a cell phone which has a button. So I think here is quite similar. I think that you don't need those many things to build a system that can help other people to use machine learning. So. But even so, I think that one of the things that I have been learning is that the algorithm is very important, but it's not in the total. When you really want to measure the impact of a machine learning application, the algorithm is not that important. It has some relevance, but it's not the most important part in machine learning, right? So these are the stages of building a machine learning application. You know, you need to first phrase a problem as a machine learning task. And this is I think it's very difficult. And we see many people that they want to use machine learning and they don't know how to put the data in a way that really can be used by machine learning engine to build something that is meaningful. All right. So that is the first task. When you know that you want to solve this with machine learning, you need to get the data. You need to either retrieve the data, you are already collecting them, collect the data, aggregate the data, bring more data from outside your company. You want to do something nicer. And then the key piece is the feature engineering. Deciding what are the features that you're going to be using to build the model, and you need to do any transformation. You need to generate a new feature. That is very important. That is the key ingredient of doing machine learning. The algorithms are not that important. Without the feature engineering, you can do the best features in the world to the worst algorithm, and you're going to get something more or less decent. But if you get the worst features in the world to the best algorithm, it's going to be very difficult to do that. You know, probably deep learning and it will be very helpful in the future in this kind of things. But now, I think is the way it works. So, what we have seen before, what BigML is doing is learning from data, and it's helping you and giving a pre-evaluation of your model, telling you, well, in a scenario where where the data doesn't change, the data that the model is going to be classifying is not going to be changing too much from the data that you use to build this model. This is going to be more or less the level of accuracy that you're going to be getting. It's hard to measure the impact, and I'm going to be getting back to this later, but that is the most difficult part of machine learning. I think that the two parts that I consider more important, building the right set of features, and then having a way to measure the impact. And I think that there's not too many people researching in that direction, not too many ways to do that, and I'll elaborate more on that later.
So BigML does this length for data pre-evaluation that, after all, is not that complex, all right? And I think that the impact of the algorithm in the whole thing is not that important.
And just we decided to do just classification and regression, and started with a couple of problems. And from all these techniques, we decided to choose trees, and I'll explain a little bit more about that. But just with solving these two problems, there's a huge amount of applications that can be built on top of the platform. So I think that just bringing a new algorithm or bringing a new technique, that doesn't contribute that much to having a system that can be helping people to bring machine learning to the projects, right? So, and I think that we are seeing that there are other platforms like Google Prediction API that they have a bunch of models, so different techniques that they run in the same data set, and they tend to choose what is the best model for your particular data set. And we were running a throwdown early in the year. Well, we did the first version last summer, where we were comparing our single models against Google Prediction API, and we were tying in the number of the accuracy of the models. We take like 11 data sets from UCI, and we do all these kind of scientific comparisons of both services, and we were more or less giving the same results. But as soon as we started using ensembles with our trees, we were beating Google. We were doing a much better job than Google using all this model selection for a particular data set. So, I mean, after all, it's important to choose one of these techniques or an approach that works quite well and adapt to a number of cases. But it's not important to have so many different ways, like as Weka has or Key9 or all these tools where finally the user has this paradox of choice, where the algorithm that I should be using, there are many different things. Or you need to read the books, you need to understand very well before clicking what is the algorithm that you want to choose, right? So, and the reasons why we chose trees, there are many. They are very highly scalable, easy to understand by people. But the thing is, the trade-off between understanding the past, helping people to see that the model really explains the data, and predicting the future is very good. It's what I was telling before. A single model helps you understand the past, and it's something that you can compound together with other models to predict the future in a very, very accurate way. If you follow the Kaggle competitions, you know that most of the winners in many of the contests are always random decision forests, are ensembles of trees that are put in together. So they do quite well. One more reason to do the trees is this is a tree from Weka, and we couldn't see that. We need to build something beautiful. I think that. And this is another company that is doing machine learning, also very, very nice company, but their trees are also ugly. So we couldn't see that, and we need to make our trees very beautiful and inventing more things around trees like sandbars. All right, so I think that one of the challenges that we have now is, well, what are the next problems that we want to solve? When is the point in time when we decide that we have explored trees, or we have helped many people to bring trees to their applications, and now we want to bring another algorithm. So that is something that we have implemented different versions of naive Bayes, a number of things, but we don't know when is the right point in time to bring this, and how we can help people visualize these other models. So
is it decision based in part on see certain classes of problems that don't fit very well with random decision forests?
Yes. Like market basket analysis is something that we have in mind, that can help also many people, and we are working with how we can visualize that, we can help people understand
Is
it.
recommendation another example? People don't have for that.
You can build, there are people now building recommender systems for classifiers. They're smart about, they don't build the whole matrix. They select a number of users, they select a number of products, and they use just the cartridge that we do to make this recommender. And they work pretty well. And as I mentioned before, just solving one more problem is going to be increasing dramatically the number of applications that can be built on top. And as I also mentioned before, I think that there are tasks that are more important than the algorithm or the new technique. That is all this feature engineering, where we are thinking that probably we could bring some kind of templates that could help people to do this feature engineering automatically, without needing to do this job by themselves. I think that we are aggregating a lot of knowledge about how people are bringing features to the system and learning a little bit about that, and probably exposing these templates out there, so that it makes very easy, for example, to a new user to build a recommender system. Explaining how you can denormalize your database, to build a recommender system, and helping people in that process of phrasing the problem as a machine learning task, and also bringing the features to the system. So that are things that we're considering. The second challenge that we face is the user diversity. We have people that are expert using the system because they want to quickly compare what we are doing with the things that they are using right now. We have people that we are part of the toolbox. They use BigML or Weka, and they also have R or whatever. This can complement what they are doing, but that gives us. When we want to bring a new feature, we need to decide if we want to bring something for the experts, or we want to do something that makes lives easier for the people that are starting with machine learning. And then we brought evaluations because there were many people that were asking, I need evaluations, otherwise I'm not going to be using your service, and we need to put evaluations in there. But probably the way we want to bring evaluations to the service is completely different. It's like a red dot or a green dot that tells you that model is something, when you press one click, it's something that is ready to be used or not. Is the data good enough to build a model? Is something that you can trust or not? So the trade-off between serving the experts versus serving the people that are starting, is something that is very, very challenging. But we try. I think that one of the metrics that we use is trying to do things always that help people in the time to productivity. Just trying to do things that if you want to get a model in production, if that can help people to make that happen, so we prioritize that first. All right, and this is also something very, very curious. There are people believe that the data is bigger than really is. People that talk about terabytes or petabytes, and once they structure the data, when they phrase the problem as a machine learning task and they start analyzing the data, it turns out that it's not that big. So we're seeing many companies that tell us, well, I have terabytes of data. How am I going to be sending you these terabytes of data? And when they start playing with it, they see that the data is only in the gigabytes, or it's even in the megabytes for certain problems. And it's not that big. I think in the feature, and if you want to analyze something really, really huge, there are companies that have that size, but most companies that don't have that huge amount of data yet. And so we prioritize the number of jobs. I think that when we prepare the infrastructure to run everything, we make sure that we are capable of running multiple small jobs at the same time, and I'll elaborate more about that later. But rather than preparing the infrastructure to running huge jobs, just one or two a month, we prepare to everything that I was doing before. It was against our production system. Everything was happening almost in real time, And probably in that process, there were other users using the platform, and we were auto-scaling and down-scaling our platform, and nobody saw that, But we were doing many, many complex things behind the scenes to make that happen. Simplicity, that is something, it's the dilemma of the company. We want to make machine learning simple. So we believe that any fool can make something complicated, but it takes a genius to make something simple. And it's not that easy. It's something that it takes many iterations and repeating things and evolving things and throwing things away, and that is sometimes it's very complex. People have built something.
Before you get too far away from talking about scaling, you said you don't use Hadoop.
No.
But that's cool. But how do you scale then? I mean, you're certainly talking about, gigabytes.
Yeah.
So
we use string algorithms. We are streaming. We're streaming the data through the processor, and we don't need to distribute the data to multiple nodes to make the comparison.
So that's for the scoring or for the training?
That is for the training.
Okay. So what's your...
But when you go beyond the training to the full data set, how about?
No, for the full data set, you can using streaming algorithms, you can train any amount of data with just a single processor. The bigger the processor is, the more CPUs, the faster it's going to be finished. And our algorithm can also be distributed to multiple machines. You can parallelize that if you want, But you don't need to use Hadoop at all.
So
I think that more and more people are seeing Hadoop. We were talking about this a couple of years ago, and people were telling, well, you're crazy, We're coming, I'm from Oregon. I'm originally from Spain. I live in Oregon. I was coming to all these VCs that were investing in Hadoop, many companies throwing millions and millions. That is crazy. and now I think there are more people that are seeing that Hadoop is a nice way to do storage. It's much expensive than using S3 from Amazon, but it's a nice way to store your data. But to do processing on top of Hadoop, to implement an algorithm that is sophisticated is complex. It takes a while to do it right. You can count, you can clean up data, you can do a number of things, and I think it's a fabulous tool for that. But for doing something sophisticated is adding a complexity. This is a nice article by some folks from Microsoft. There was something like nobody was fired for installing Hadoop in a cluster. You should read that paper.
So how do you scale it up? I mean, if you're streaming the data in, how do you?
So we have a queue. We use rather than queue, we have a queue of jobs, and then we know exactly how many nodes we have in the architecture that they're doing tasks. I can jump to that here. What we are doing is preserving the structure. The same thing that we are seeing when we create a data set, a model, the same logical structure that we have in the application, we're using that in the backend. So we have a mini cluster here that is for sources, data sets, models, and then what we have is like a fast track. The same thing that happens when you go to the supermarket, that you have a track, you just come with a few products, you can go and run very quickly, so that your response time is very small. You don't need to wait along in the same queue. So we have that. Everything that is very small run through the fast track. Everything that is very big, we use the queue. We are smart in the way we are auto-scaling because we pay Amazon by the hour. So if you're going to be running a job that is going to be taking 3 or 4 hours, we can make that job wait for 5 minutes, and we can see if there are many other jobs that are coming, and then we can decide how many machines are going to be added here. In this case, for example, this is for doing evaluations. We have many evaluations coming at the same time. So we are looking at the queue, and we have some kind of smart auto-scaling. So we decide how many processors we're going to be adding here. I think that is one of the great things of using the cloud. You can take resources when you need them. And you can dismiss the resources when you don't need them anymore.
Are you using spot pricing?
We're using a mix of that, and sometimes we tend to be smart about that.
So how do you charge? Do you charge as an add-on to Amazon, or do you use a different formula?
It's coming.
It's coming, okay. And then a related question is, if you're running everything through streams, do you often have to do multiple passes to the streams? Because I can see for decision trees, you know, you could do it as a one pass potentially, but there are other algorithms, if you get into it, you may have to do multiple passes.
Even for the trees, we need to do multiple passes.
You do,
for the
okay.
for the histograms, we do a pass, you know, and then for the trees, there are times where we do multiple passes. But we are streaming the data always. We don't need to keep all the data in memory at the same time, you know. We do all the
Okay, but the
computation.
streaming, the number of passes doesn't grow with the size of the data. It's
No.
Yeah, it's fixed by the
Yeah,
algorithm.
by the algorithm.
Yeah.
And then for example, the number of beans that we are using in our algorithm now is very is huge. We are using like 512 different beans for the weak learners, for the splits, and things like the random forest that they are using in Kinet. They are using just 10 beans.
Okay.
For doing things in real time, you can, and these parameters are things that we keep behind the scenes. At some point in time, we want to make this open for the people to be able to use that. But depending on those, the number of passes that you need to be over the data is bigger.
So if the concept of doing streaming is like a strategic imperative of the company, that does limit the kind of algorithms you can do.
No, I don't think so.
You think you can map any algorithm?
I think I don't know if that can be formalized, you know, that can be but I think that we can transform many algorithms to be using the stream. It's the way to make big data small.
Okay.
Okay, so we went in simplicity very quickly, and just my message here is that making something simple goes beyond just making an easy to use interface. It's making the installation very simple, configuration very simple, how you train very simple, the models that you create very simple. It means that the whole thing needs to be very simple. As soon as you have something that is very complex or a little bit more complex, the whole thing is going to be, it's like the weakest link, you know? The little more complexity in the service, something that people don't understand, and we want to make things simpler and simpler over time. I think that is one of the challenges, all right? In terms of scalability, very quickly, when you use R9 or Weka, you know, you can always use cluster, a number of things. They have all kind of connectors to do that, you know. But usually you're running just one job from one user, you know. And even if the problem of many of these algorithms, you tend to train a G40A in Weka for a 5 gigabytes data set is probably going to be crashing your machine, you know. So solving that is complex, you know. Creating an algorithm that for a particular data set of a specific user scale very well is complex, you know. Tend to do the same thing. Tend to run a number of jobs for the same customer, you know. Something like Sky3 is doing, you know, where they have like a specific server that they install behind the firewall, and you can put many of these servers, and you can run many concurrent jobs at the same time. It's a little bit more complex, but then to run multiple jobs from multiple customers at the same time is a little bit more complex. This is what Google Prediction API is doing, is what Wise.io is trying to do, is what BigML is doing. You know? I think that we have that challenge. We need to have that infrastructure behind the scenes, you know, that grows and shrinks depending on the number of jobs that are concurrently in the system. You know, it's not that easy. Before going to the pricing, I think that this is the key thing for me, is how you measure machine learning impact. You know, how you know that when a machine learning algorithm is making a prediction, imagine that is predicting that Alice is gonna be buying a specific product, a magic potion. You know, what happens if the magic potion is out of stock? You know. It's something that you consider that a false positive, or it's a problem with with the data scientists that they didn't include that feature in the data, or we need to blame the false operations because they weren't having installed things that people are going to be asking. You know, how you really evaluate the impact of an algorithm in dollars. You know, how you can measure that. You know, and I think that is very complex. There's this super inspirational and provocative paper from Kiri Wastaf last year at the ACML. There's even a website that is collecting part of the thoughts that they were created after this paper. And I think that she was talking about this big disconnect between the machine learning research community and the real world, you know. And the researchers, they have been creating or improving these algorithms with static data sets for many years without caring about what is the impact of these algorithms in the real world, you know. And I think that I'm taking a few of these ideas, you know. I think for building this stage of a machine learning application, I think that the most important thing is measuring the impact, and it's one of the challenges that we have, you know. How we can tell to one of our customers that really this algorithm is helping and then to make this. We know that they are saving tons of money because we are cheaper, because we are faster, because the time to productivity is smaller. There's a number of things, you know. How we can tell them that they are making this much money? And if we know that as a business, that is great because we can charge more for our service, you know. We don't need to, but we are in some sense we are commoditizing machine learning, making it very cheap. So about pricing, so when you sign up, your development mode allows you to do everything under 1 megabyte for free, and you have a number of credits that we grant you for free too. I think it's 10 megabytes or 20 megabytes that then you can use to create your data sets, model, predictions, evaluations, these things, all right? And you can buy more credits, you know, and you can select how much you want for data sets, for models, or for predictions, all right? And depending if you buy based on megabytes or gigabytes or terabytes, the price per credit is going to be different, all right? And then what we were seeing is that many people were buying credits, and then they start becoming like heavy users, you know, trying different models. I want to try this model and selecting this feature, all right? When you create a model, you can unselect features. You can start playing with the application, and then we were penalizing the heavy users, you know, the people that really. And so now we're bringing subscriptions. You pay a monthly fee, and you can use the application as much as you want. You know, you can create unlimited tasks in the application. And the things that we are limiting is the size of the task, you know, and the number of concurrent things that you can do in the system. That's all. And now we know, well, if someone is very heavy user and is taking this plan and is training 4 gigabytes every few minutes, you know, it's going to be at the end of the month that is going to be a terabyte of data that is training. But we know upfront that there are not those many users with so much data, you know. So there will be a few users that cost us money and a few users that make us a lot of money.
Are you providing any incentives for word of mouth advertisement? For instance, like Dropbox, if somebody forwards you a new customer, maybe to get some extra space on the account?
So thank you for asking that. So once you sign up, all right, if you recommend BigML, you have this special link for you. And if you recommend, you can get a 3-month free subscription, you know, that can allow you to analyze a lot of data, all right? So every 3 friends that you bring to the platform, you get a free month.
What do you mean by month? Since you mentioned credits.
No, that you can use the way it works is when you have a subscription plan, you don't consume your credits, all right? But imagine that you have a plan that is you have this plan that I'm using here that is to 1 gigabyte, all right? But now, for whatever reason, you have today a data set that is 4 gigabytes, you know? So you can just prepay for that special data set, but your plan is going to be allowing you to run everything under 1 gig for free. Now for free, but once we have the payments in place, you know, it will be we don't know for sure, but probably we're going to be starting like $30 a month, and you can get that to be 1 gigabyte.
What's the biggest data set that anybody has done with BigML so far?
Huge. bigger than the plans that we are offering.
Is there any facility to like import trees? Like, let's say I've done a tree in another software product, but I want to bring it in to see your visualization to get familiar with it.
No. What we are doing is the visualization, both things, the trees and the sandbars, is something that we're gonna be probably making public, so that people can, if you build a model, you're gonna be able to integrate the model in your own application.
So would we be able to upload link or do an API call to our own website?
Yes.
For our results?
We already have a few examples of that where people are using the sandbars directly in their own applications. And yes, very quickly to finish. So this is what we want to do, just one-click model and being able to eliminate all that complexity, one click, and eliminating all the complexity of distributed systems. And this is how I see things now. This is 2013. There's a bunch of applications, packages that you can use to do machine learning, and I think that we are a little bit easy to use than these other packages out there, all right? But if I zoom out and I try to see the feature, I think that we are still very low. There's a huge space for improvement. And I think that the improvement is not going to be linear. We're not going to be making things easier and easier. There will be a point in time, hopefully before this date, where we come with an innovation. And at the same time, I think that there will be more and more people knowing about machine learning, hundreds of thousands of people taking the Coursera class, these kind of things, There will be a point in time where we'll come with an idea, that make machine learning really simple. And I think that we're working hard to make that happen, but we don't know when it's going to be. Yes?
What's your roadmap for like some other kinds of algorithms? Because you said like you have supervised, but there's a good case for unsupervised.
So far we don't know. We don't know. There are many people that would like to see here, some kind of manifold learning, and many different things that we could be doing, but we don't know. We don't have a. I think that we want to adapt to what we see now with people using the service, and at some point in time we'll bring probably a nice way to do clustering, a nice way to do semi-supervised learning, but we don't know yet. I think we'll try to bring more things to keep the people happy with their subscriptions, but we don't know yet.
Any plans to open source it or you can run on your private clusters?
Say again?
Any plans to open source it or do community editions, or you can run it on your private clusters if possible?
No, we don't think so. We open source a number of things, our bindings, our open source, our closure library for sampling. Everything that we use behind the scenes to do the sampling is open source too. We have been open sourcing part of the components that are critical to do machine learning, but we don't think that that offering, the way we are, we call Wintermute, that piece. I don't think that we're going to be open source that.
So, are there very many more questions? We need to get to the raffle here, but. Okay, I don't see too many more questions, so maybe now is a good time.
I have just one question.
Oh, okay, sorry.
Excuse me. Yeah, so the question is, you showed the ability to purchase someone else's model.
Yes.
So how is this popular in your application? How many users are using that, purchasing?
So we see a few people every day buying other people's models. And then there is an incentive to make money. You can make money out of that, but the money that people are making now is very small. It's not.
But there's interest.
I think that we're going to see more people bringing data to the system. I think that bringing a nice data set is something that can take a while. When people have those, it's a nice way to expose your data, to sell your data without selling the actual data. You're selling the structured data set.
Okay, we're going to cut off questions now before everybody leaves.
I want to thank the speaker very much.